domain of a function. If a function is defined as y is equal to fx, then all the values of x for which the function is defined, that means values, that is a basic definition for finding the domain of a function. Values of x for which function is defined. Function is defined. So now I have to understand what is the meaning of word define. Different types of functions we encounter. If a function is in the form of something divided by something, the first rule we have to remember that denominator should not be 0. That means denominator should be some positive thing. Rule number 2. The things or expression inside the even roots should be positive. Suppose it is x square minus 5x plus 4. So this function to be defined, this should be positive. That means x square minus 5x plus 4 should be greater than or equal to 0. Yes, you are getting different values of x for which the function is defined. Logarithmic function. Rule number 3. Both a should be positive and b should be positive and b should not be 1. Then the function is not defined. This is very much obvious. So what you have to do for finding the domain of a function, you just follow the things for which the thing is defined. You will get the corresponding values of x. That is going to be the domain of the function. For trigonometrical functions, you know, sin x, cos x is defined for all real values of x. Whatever value of x is there, it got some definite value. This got some definite value. So what's the domain of this function? All real number. But tan x and cot x is defined at all values of x except odd multiple of pi by 2. That can be written as 2n plus 1, odd multiple of pi by 2. X should not be this. Everywhere else, this is defined. For inverse function, you see, sin inverse x, cos inverse x, x should be between minus 1 to 1. So what is the domain of this function? X should be between minus 1 and 1. Tan inverse x and cot inverse x, you know, is defined for all values of x. So what is the domain of tan inverse x and cot inverse x? All real values. Now see, a to the power x, constant to the power variable, x can be any real number. X belongs to R. So domain of this function is all real numbers. Certain rules you have to keep in brain while solving inequations. Suppose a quadratic inequation is there, ax square plus bx plus c. Some inequation may be greater than or less than equal. If you have to decide the sign of this expression, you just see what is the discriminant of the corresponding quadratic equation. If d is coming out to be less than 0, that means roots are imaginary, then the sign of this expression will be as that of a. Is it clear? Now we will see some more inequations. Suppose log b to the base a is greater than c. How can we solve? A to the power c will be greater than b if a is greater than 1, or it will be a to the power c is less than b if the base is less than 1. Of course, it has to be positive. Certain modulus functions in equation we will deal with. Suppose modulus x is less than k. What does this mean? X should be between minus k and k. Suppose modulus x is greater than k. What should be the value of x? X should be either less than minus k or x should be greater than k. So keep these basic things in view while finding the domain of a function. You will get easily the domain of the function. Suppose a composite function is there, means it is x square plus sine inverse x plus a to the power x, like that a function is there. Okay, for finding the domain of that composite function, you individually find the domain of first function, second function, third function. It may be in the form of into, it may be in the form of division. Anyway, so many functions are there. You find individually their domain and find intersection of their domains. Suppose the domain of first function is d1, that of second is d2, that of third is d3. You get domain of the individual functions, then find their intersection. You will get the domain of the resultant function. Hope so. This knowledge is enough for finding the domain of function.